BRDF Materials and Military Applications is a current research effort at the VGL at USC's Institute for Creative Technologies. BRDF determines how much light emitted from one direction is reflected in another direction, depending on the material's properties. It is widely used in computer graphics to simulate realistic lighting and shading on surfaces. High-fidelity simulations for soldier training use BRDF to accurately render realistic lighting and shading of objects in virtual environments. This ensures that materials like uniforms, vehicles, and terrain look and reflect light as they would in real-world conditions. Utilizing BRDF allows us to change the material of the object, in this case a plane, so that they blend in with the surroundings. It can be used for stealth training and camouflaging objects in a scene. BRDF also provides us with detailed material information about the detected target for identification. The VGL light stage is a capture device with controllable lighting and cameras, allowing us to record both the incident and reflected light. This enables the acquisition of ground truth material properties of faces and objects. As seen here, we have an object being scanned in the VGL light stage. Unlike faces, objects are not as easy to capture because they are anisotropic and reflect light differently than skin. Hence, we use the dense one light at a time to record object BRDF. Process the data captured in the light stage utilizing our optimization pipeline, allowing us to achieve higher accuracy of the diffuse and specular normals. We scanned over 200 objects in 12 different classes for our materials database. The object surfaces are composed of varying types of materials, such as transparent, glossy, with and without fabric, sheen and without sheen, various fur types, and a variety of others. We trained a material authoring network based on our object database to generate BRDF textures for any 3D object and input material query, like carbon fiber, steel, or Kevlar. We then apply these textures to the 3D model using offline rendering or a neural shader. Using our pipeline, we are able to generate textures of different materials and apply them to 3D objects, like you see here with the military tank simulated in Blender. The texture generation is fast and inexpensive, taking approximately 100 seconds to generate a new texture. The application and simulation can be achieved on the fly. Inversely, we can perform material analysis for target detection and remote sensing applications as well. We are able to apply camouflaging using image-based relighting with applications for blending objects into their backgrounds. Using IBL, an army tank can seamlessly meld into its surroundings so that it's less detectable. Here we see the environmental lighting as a reflection on the vehicle. The Navy warship blends into the environment because it is being relit by its surroundings. And metal on the plane and helicopter reflects whatever environment it finds itself in, desert, ocean, or snow-capped mountains. For more information on the BRDF project, please reach out to the contact here.